This video provides general information on the capabilities of Mark Williams Enterprises Incorporated. The purpose is to provide information on the history, culture, and the capabilities of the company. We are located in Denver-Boulder area in the Colorado Technological Center Industrial Park near the town of Louisville, Colorado. The plant occupies a 32,000 square foot building that is in the shadows of the University of Colorado and the Flatiron formations of the Rocky Mountains. Since the company's humble beginning in 1964, Mark Williams Enterprises has become noted as the most self-sufficient mechanical design, testing, and manufacturing companies in the racing industry. Originally started in the early 60s as a race car chassis manufacturer, the company has evolved into a one-stop numerical controlled manufacturing operation that specializes in the design and manufacturing of racing and industrial driveline related products. The company is noted for applying the latest technologies that allow superior quality and prompt product delivery. Mark Williams Enterprises was one of the first high-performance manufacturers to utilize a computer ordering, part producing, and shop floor control systems. By focusing on our core competency, the designing and manufacturing of driveline components has allowed us to have the reputation for the best products available. This includes in-house product testing, which plays a major role in affirming new designs and ensuring the quality of existing products. In this section of the video, we will show you how to make the world's finest drag race axles. We will show you a step-by-step process of the high torque and the Masterline axles, which are completely produced in-house. We start with raw forgings made from 3 different alloys, depending on the application. In this section, we'll focus on our most popular, the high torque axles. All axle orders are produced on a computer system that uses the customer's information and requirements to calculate the axle lengths. Verification is sent to the customer to double-check the lengths, preventing any ordering errors. An additional bonus to using this form is that it may also be used to build the correct housing width when the customer knows the desired wheel-to-wheel width, but not the actual housing dimensions. The axle forging's first turning operation is performed on an Akuma CNC live tool twin turret lathe. The flange is turned from the raw forging, leaving material in critical places for subsequent grinding operations. With the same chucking operation, the bolt pattern and any additional holes or pocket profiling is performed, assuring concentricity of all the features. The axle is then chucked with precision jaws on the previously turned flange diameter, while a live center supports the opposite end. The shaft portion is simultaneously turned from both upper and lower turret, which allows a smooth, chatter-free finish. All the high torque series axles feature a reduced section after the spline for 1/3 of the axle shaft. This allows torsional windup to occur in the reduced section, preventing spline deformation. The remainder of the shaft is tapered just below the bearing diameter, creating a stiff triangulated column that reduces the axle bowing. While in the same chucking, an MW designed and patent pending hobbing attachment is used to generate the involute splines. This exclusive tool allows the splines to be perfectly concentric with the turn diameters. The fit and the surface finish is exceptional due to the numeric control of this process. Some models of the high torque axles are available with a gun drill option. The machine was specially built to perform this option in-house. It is capable of drilling several sizes through the axle material stock up to 42 inches long. The gun drilling option is popular for reducing the overall weight of the axle assembly. Following the gun drilling, some models are given an additional honing process. This creates a super smooth finish that eliminates the possibilities of stress risers forming from the inside of the axle shaft. It also creates an extremely accurate bore diameter for subsequent operations. All of the 300M material axles receive this additional honing process. After the turning, the axle is then micro-polished to assure a stress-free surface. The MW high torque axles are heat treated using a special process called OS tempering. The axles are held vertical in stainless steel fixtures and heated to the austenizing temperature in special designed salt bath furnaces. The red-hot axles are quenched into a lower temperature salt bath, which makes the axles hard. The resulting structure is a high-strength steel that maintains its ductility. Even though the austempering process and vertical handling eliminates most of the distortion issues, a fine-tuning straightening process is required. While the axles are still at the elevated quenching temperature, the axles are straightened using an E-tel stroke control press. This specialized machine is capable of straightening the axle shafts within 0.002. Following the heat treating operation, the axles are magnetically inspected to guard against surface and subsurface flaws. MW uses a DC-powered aircraft magnetic inspection machine capable of detecting flaws as deep as a 1/4 inch below the surface. The final machining operation is performed on Akuma CNC angle head grinders. This process controls the bearing seat distance for an extremely accurate position of the disc brake. A very important feature is that the grinding wheel is freshly dressed before each grind, creating a perfect radius at the bearing seat. This is critical for preventing cracking problems at the bearing flange. The bearing diameter, seal surfaces, wheel and brake drum registers are all ground in one operation, creating perfectly concentric diameters. Each axle receives a protective black oxide surface treatment for rust prevention and appearance enhancement. Then the Mark William emblem is attached. It's a universally recognized symbol of quality. The 50100 axles are the standard high torque axles that are solid. The 50400 Pro Street axles are used in conjunction with special housing end kits that utilize a Timken unit type wheel bearing. This combination is ideal for heavy duty street applications. This axle is often used with our 35 spline 9-inch Ford locker that has proven extra dependable for heavy-duty street applications. 50500 high torque axle is the gun drilled and pocket lightened version of the standard axle. 2 different gun drill diameters are available depending on the axle spline. 11/16 diameter is used for the 35 spline, 7/8 diameter is used for the 40 spline axles. Either axle requires a 45mm diameter wheel bearing. 50800 high torque axles are the 300M material super lightweight versions. By utilizing the extra strength properties of this material, the gun drilled bore can be increased without sacrificing strength. These axles are utilized in applications requiring the strongest axle, desiring a weight savings advantage. 50900 Evolution 4.1 axle system uses a spherical wheel bearing that features a shell retainer system. This improvement allows for extremely rapid between-round removals for differential maintenance. This configuration eliminates the binding problems of standard Conrad-type wheel bearings. This system includes a special housing end and caliper brackets that can utilize the MW or Lamb disc brake kits. In this section, we'll show you all the different drive shafts available at Mark Williams. MW produces 2 different types of steel drive shafts. Steel drive shafts are available in mild steel and 4130 chromoly tubing. They are available in 3-inch, 3.5, and 4-inch diameters. These drive shafts are used for both drag racing and street applications. There are multiple types of aluminum drive shafts available at Mark Williams. The welded aluminum version uses a 6061 T6 tubing and end fittings. It features a welded construction using the MIG welding process. The MMC aluminum drive shaft is the strongest aluminum drive shaft available. It utilizes a patent-pending AccuBond process. This eliminates the strength limitations associated with any aluminum welding process. Bonding also allows the use of 7075 forged end fittings that greatly enhance the strength. Many models of the MW drive shafts receive a torsion testing procedure. The shaft is proof tested and cycle tested before shipping. This extra step is an exclusive benefit with the shafts produced by Mark Williams Enterprises. The high-speed balancer is used to balance all shafts to a G40 specification. These G40 specifications calculate for shaft material stiffness, length, and operating RPM. This machine can balance at a running operating angle and simulated load condition. It is also capable of spin tests with special guarding that can test up to 10,000 RPM.